For today's lesson, we will be discussing about the second power theorem, which is Theorem 116. Theorem 116 is the segments of secants power theorem. It states that if two secants intersect in the exterior of the circle, the product of the length of one secant segment and the length of its external part is equal to the product of the length of the other secant segment and the length of its external part. To better understand this theorem, let's try to look at this example. Let's say we have here circle O, wherein segment DE and segment RE are secant segments of the given circle. Now, if you will see, they have a point of intersection which is point E, and point E is actually outside of the given circle. Now, after these two secant segments intersect the given circle, each of them is now divided into two parts. So, for secant DE, we have segment DS, which is the internal part of the given secant, and then we have segment SE, which is the external part of the given secant. Same case with secant RE. We have segment RC, which is the internal part of the given secant, and then segment CE, which is the external part of the given secant. Now, if we will apply the theorem, we can say that if we multiply the length of one secant segment to its external part, then it should be equal also to the product of the other secant segment and its external part. So let's try to write first the equation based on the segments here. So first, let's get the secant segment, which is segment DE. Now let's multiply it with its external part, which is segment CE. Now this should be equal with the product also of the second secant, which is segment RE, and its external part, which is segment CE. Now, since we have the measurements, we can substitute to check if this is correct. So segment DE is 12, segment CE is 4, segment RE is 8, and segment CE is 6. Now simplify, so we will have 48 centimeter equal to 48 centimeter as well. So as you can see, the product now of the segments are both equal with one another. Let's have this example. Let's say we have here a circle wherein segment SB and segment SD are the secant segments of the given circle, and their point of intersection is point S, which is outside the given circle. Now, each of the secants is divided into two parts. We have segment UB, which is the internal part of secant SB, and we have also segment SU, which is the external part of the first secant, which is SB. Same case with the second secant. We have segment LD, which is the internal part, and segment SL, which is the external part of secant SD. Now, if CL is equal to 12, DL is 18, and SU is equal to 16, we need to find the measurement of SB, which is the secant. Now, let's write here the formula. We have SB, which is the whole secant, multiplying it to its external part, which is SU. Then it should be equal with the product of the other secant, which is SD, and its external part, which is SL. Now, we just have to substitute all of the values. So, we don't know SB, because that's the one that we're looking for. SU is given, which is 16. Now, we don't know SD, or the measurement of the whole secant, but we have its parts. So we have SL, which is 12, and we also have DL, which is the internal part, which is 18. Now, to get the whole measurement of SD, we just have to add it, and that is 30. Now, multiplying it with the external part, we have 12. Simplify everything. So we have here SB times 16, then 30 times 12 is 360. Then to solve for SB, just divide both sides by 16. This will be cancelled. Then we have SB, which is 22.5 units. So that's it for today. I hope you learned something about the second power theorem and see you next time.